All right, let's get started. Hi, I am Florian, or rafl if you prefer, and this is Ansible for Programmers. The big idea here is that most of you probably have pretty extensive programming knowledge in be it Perl or any other languages, and you spend years trying to learn proper engineering or proper software development techniques and just learning how programming languages in general work. And I want to help you take that knowledge that you have of programming and software engineering and help you carry it over to this tool called Ansible, which is a pretty neat tool if you want to automate pretty much anything, as long as it's got to do with computers. But before I start, I just want to say thank you to Infinity Interactive. I did write this talk as part of my work for them, and even though I'm no longer with the company, they did allow me to give this talk anyway. So thank you for that. Now, just like with Perl, there's many different ways to use Ansible, and I'm going to walk you through a bunch of those. But one thing that they do all have in common is that they rely on something that Ansible calls an inventory. And you see an example right up there, and the idea is that you tell Ansible about how your infrastructure I should start that timer. How your infrastructure looks like. You tell it about all the different machines that you want to automate certain tasks on, and it also gives you the possibility to sort of group the different machines that you have into different groups. So in this example, we got a local group with just localhost. We got one server that runs an application called Picard, and another one that runs Adama. And we also got at the very bottom there an app servers group that is sort of composed from the members of the other groups. Typically, you'd have a lot more machines in there. You wouldn't just have a group of one machine most of the time, but this is just a little illustrative example. Okay, so say you've written one of those inventories and you actually want to run things on those machines that you just told Ansible about. And one of the ways to do that is using ad hoc commands with the Ansible command. Here are two examples. The first argument in both cases just tells Ansible which of the machines from your inventory you want to run commands on. First example is just going to run it on all the machines in inventory. Second one just does it on a specific subset. And you can do fancier things like combine groups together or exclude certain hosts, but this is the simplest example. And in addition to telling Ansible on what machines you want to run things on, you also got to tell it what you actually want to do, which is what this little -m parameter in the end there is for. It stands for module, and Ansible basically is a collection of all kinds of different modules that can do different things like running commands on remote servers, transferring files, making sure a service is running. But the simplest module that Ansible has is the ping module. Just connects to the server and reports back to you whether or not it could connect there. And that's the ping command. That's not very useful though. So let's look at actually running a Unix command. For that we use the command module. And to tell it what command you actually want to run, we got this little -a parameter there in the end, which is how you specify arguments to the Ansible modules that you're trying to run. And here's just a slightly more complex example. We're trying to create a user, and as a parameter, we're going to give it the name of the user to create and the password for that user. There's all kinds of options you could supply there, and they're quite extensively documented. You could ask for the home directory to be located here or there. You could specify the login shell for the user and so on. And basically for most of the time, for modules that take several parameters, you would use this sort of key value style, key equals value, just to supply all the option to the modules that you need. And this is really useful for sort of one-off commands, or maybe as you're developing something larger to just be able to try running a certain module with certain parameters. But most of the power of Ansible actually comes from a second way to use it, which is through Ansible playbooks. Those basically allow you to glue together a number of those module invocations that we just saw on the previous slides. It adds error handling. If something goes wrong, it's going to bail out unless you say it shouldn't, stuff like that. And it gives you many kinds of features that you will be used to from programming in other languages, conditional loops, that kind of stuff. So Ansible is effectively a programming language, though it isn't usually marketed as such or documented as such, which I think is because it doesn't have its own syntax, really. You're just writing YAML files, and then there's something that reads those YAML files that sort of acts like an interpreter for the language. It's weird to program in YAML. So that's the thing, anyway. And this is how it would sort of look like. This is quite a lot of text on the slide, so I want to go through it piece by piece. So this is called a playbook, and it consists of a number of plays. It's basically one big YAML list. And we just get one element in this list here, and everything else is sort of indented under it, right? So this first statement says that we want to run this particular play on all the servers that are in our PostgreSQL server group, which you would have to find in your inventory and just list all the database servers under it. And after telling it where to run things, you also got to tell it what to run, which is what this little task section is for. And these tasks are what we're going to spend most of this talk with, so I'm just going to gloss over the details here and just show you the rest of it. So there's many different sections that you can have in place like this, including handlers that are going to be called just like a callback once a certain thing happens. In this example, whenever the PostgreSQL configuration file changes in any way, it's going to make sure that PostgreSQL actually gets restarted. But anyway, so let's focus on these tasks and get rid of this little notify thing here. I color-coded these a little bit because there's like a one-to-one mapping between these statements up there and these little ad hoc commands that I showed you earlier. If we go back to these and color-code them the same way, you can sort of see how this corresponds. In the playbook syntax in YAML, you basically use the Ansible module name as the key and then the value on the right-hand side of the colon are all the arguments that you're going to pass to the module. So for example, in the task at the very top, we use the app module, which knows how to install and remove packages in Debian, and we just ask it to install PostgreSQL 9.4 of the latest version. Okay, and once we got those things written, we got to run them, and in this case, you would use the Ansible Playbook command rather than the Ansible command, and you give it the file that you saved your playbook as, in this example, site.yaml, and you're also going to tell Ansible Playbook about your inventory, so it knows what you mean when you say do something on all the PostgreSQL servers. All right, so just looking at this very, very basic example, you can see a couple of things that might bother the average programmer. There's a couple of things hard-coded in there, such as the PostgreSQL version. If you want to upgrade to the next version or downgrade or something, you would actually have to go through all of your playbooks and roles and whatnot and find the right strings and replace them and be sure that you don't actually forget any of them. So it would be a little bit nicer to be able to just factor that out and just have that in one place so it's easy to change whenever you have to. And that is what variables in Ansible are for. You could introduce them just like that at the top there, just as a key value pair. The value could be a complex structure. It could be a list. It could be a dictionary. It doesn't have to be just a plain simple value. like in this example. And once we have that, we can replace these occurrences with just a little variable interpolation. And now we get only one place where we got to change things if we want to switch PostgreSQL versions. And that's sort of the first programming language feature of Ansible, just having variables that can be user-defined. Now, just like you don't usually want the text of your web page templates to just be strings in your Perl source code, you probably also don't want these variables to be declared right within your playbook. You kind of want to have a separation of the actual code that you run and the data that your code uses. And Ansible makes that easy too. You can just create a new file and call it any name you want, put your variables in there, and then rather than declaring variables at the top there, we just include this file, which is nice because it's usually you're going to end up having a lot of variables. And it's not very nice to maintain if you have those right in your code. So Ansible also has, so if you were to do that, you might have a problem though. Say you're usually running PostgreSQL 9.1 in production, and but you want to try maybe PostgreSQL 9.4 on your staging system or some such. And there isn't really an easy way to do it with a setup like this. But Ansible has a feature, or set of features specifically for that. And it is so common and that all you have to do to use it really is delete code. We just get rid of all of that at the top. And instead, we're going to create a couple of new files that Ansible knows about and will look up when it needs to. So we see a directory listing here, and we got a playbook at the very top, and we created two new directories, group vars and host vars. And basically what's going on here, we're going to assume PostgreSQL service.yaml has the version declared as 9.1. And this is going to be loaded for all the machines that happen to be in the PostgreSQL service group. So we got our default set there, but we can, for example, for our two, I don't know, staging servers or whatnot, we can override that version on a host, on a per host level by just creating a new configuration YAML file in this host vars directory. And if that name matches any of the hosts that you're working against, it's going to load those instead and override the defaults will. The question is, can you have one host vars file for two hosts? You can't do that, but you can create any number of new groups. You can just make a new group with those 2 or 3 servers that are special, and then just have a group vars specific to that. Thank you. Okay, so that's variables in Ansible, and that's all well and nice. Next language feature I want to talk about are conditionals. Those are introduced using this little when keyword there, and on the right-hand side we got a little logical expression. In this case, we're just comparing the constant Debian against whatever Ansible decided our distribution was. In general, all the variables starting with Ansible underscore are provided to you by Ansible. Dave?
Sorry, I just had a question about the last slide. The groups, are those just what you had as the headings in the inventory file?
Yes. Ansible distribution and other variables with that prefix are provided to you by Ansible. It can give you a lot of information using puppets, factor, and a couple of other things to tell you about the IP addresses and all the interfaces and things like that. And so here we just differentiate between Red Hat systems and Debian systems and appropriately either use apt or beyond to install the appropriately named PostgreSQL package. That's pretty simple. And you can't just use the Ansible provided variables. You can also define your own. In this example, we want to install Perl so we can run a Perl application. That's what the second task does there, using Perl build. You could use Perl brew or whatever else. And it would be kind of silly to just rebuild it and reinstall it every single time you want to deploy using your automation. So what we do is we add a little predicate at the very top where we're using Ansible's stat module, which can give us information about entities in the file system. And we ask for the information about the path where we expect our Perl binary to be, and we tell it to please store that information in our Perl existence variable there, to subsequently then decide to only run Perl build if that file does not exist. Because if it does exist, we're just going to assume it's already installed. All right, are there questions on the conditionals? No, good. Next popular language feature, loops. All these things look exactly the same, right? And there's no reason to be quite as verbose. So we can use loops. We give Ansible a little list of items that we want it to work through, and it's going to call the apt module at the top for every single one of them, substituting the little item variable by whatever values you listed as the items at the very bottom. And next feature, Ansible calls it includes. I personally prefer to think about them as functions. I feel that way of thinking about it makes it a lot more clearer what it actually does. So we're back at our database server, and we got to create a couple of users, or roles, as Ansible calls it. And we do this using the create user command there at the bottom. But we only want to do that if the user doesn't already exist, because otherwise PostgreSQL is going to yell at us. So what we do is we just have another one of these little predicates, and we just ask PostgreSQL whether or not that user already exists by sending some SQL query that I omitted, and we store the results in our role existence variable. And I'm sure you noticed these little placeholders there. I wasn't actually concrete about what the name of the role is or anything like that. The reason is we're just going to store the contents of this slide in a new file that we could call create_role.yaml. And we can subsequently include that into our playbook and provide sort of the function parameters. In this case, we just pass in the username that we want to create. And we can call that as many times as we want with any different parameters. And it doesn't just have to be one parameter. So this is how Ansible functions work. They're super useful. OK. Now, let's say we want to import some data into our database, and we want to do that from a PostgreSQL dump, so that our applications can actually do useful things. We could do it like this. Ansible has a very handy copy module, which allows you to transfer files from the machine Ansible is running on to your target systems. And once we got it over there, we can just use pgrestore to load it in, right? Though there's a couple of problems with these tasks. For starters, it's only going to work once. You run it once, it's going to copy the file over, import it, everything's good. Next time you run it, though, it's going to fail. PostgreSQL is going to yell at you because the database already exists, or because the relations you're trying to create in the database already exist. So things are going to blow up, and that's not very helpful. This is an example of an action that isn't idempotent, and I kind of just want to use this to start a little tangent and talk about idempotency. But I don't want to do it with the slightly more complex example of trying to load a database dump, but instead I want to use a little bit of a contrived example. This is kind of silly, but the idea is to demonstrate a bigger point. So we got an application that is called Picard, and it has a configuration file, etc picard.conf, and the Picard developers recently added a new feature called conditional get, and we do want to give that a try. And to do so, we got to enable it in the configuration file. We could do it like this, which is a way to say in shell to append a line to an existing or to a new file. This is obviously problematic, though. Excuse me. Somebody might already have added that line to it, and then you're going to end up having it twice in there. Worse yet, people could have done it on just some servers, not on the others, and you end up being unhappy because everything's inconsistent. So the idea is to not do that. What you always want to aim for is writing idempotent actions or tasks, because that way it doesn't really matter what your start state is, you're always going to end up in the state that you actually want. And to do so in this little example, instead we could just use this same copy feature that we've seen before, just maintain our own static configuration file together with the rest of our Ansible code, and then just send it over. No matter what the old file contents were, we're just going to replace it with the contents of the static file. Maybe, though, we only want to enable that feature on our staging machines for now, because we're not quite sure yet if it's a good feature. So instead, we could also use a little template and use, say, host vars or group vars that we've seen earlier to just enable that particular feature on a subset of our machines. And there's another way that I particularly like. So this is a little bit silly for this very simple, just config file example, but I think it sort of illustrates how often, if you're struggling to write something in an idempotent way, it often helps you to step back a little bit and phrase the problem differently until it's actually easy to write an implementation that is nice and idempotent and not terrible. So here, instead of just having one configuration file, we basically have a whole directory of configuration files in etc picard.conf.d, and the application is just going to load all of them. So if you want to, say, enable that new feature, you can just put a new file in there, which is easy to do even without fancy tools like Ansible or Puppet or whatnot. It's not really necessary, but it just shows how thinking about the problem somewhat differently often allows you to write idempotent solutions in a bit of an easier way. Okay, so let's just go back to our database dump example. One easy way to fix the problem we had, we could just drop the database every time before we try to restore it. You wouldn't want to do that every single time, though. If your data isn't trivially tiny, you would ask PostgreSQL to reload gigabytes and gigabytes of data and rebuild indices and whatnot, and you probably don't want your applications to be down for hours every single time you got to make a minor configuration change. So we should figure out a way to only sometimes do this, and we start out by just storing that in like its own function called restore database. So that elsewhere we can just include it, and all we got to do is figure out when to actually include it. And there's many different ways to do that. We could just say, if the database doesn't exist yet, we create it, otherwise we just keep it the way it is. Or you could go a little further and add a little switch that I called force restore here, which would allow whoever's using this Ansible code to just set this option whenever they need to reload the database from, say, I don't know, the production database dump into the QA or staging one or whatnot. Though, like, the whole point of this Ansible thing is to automate things, so it seems a little silly to me to like add more manual switches where people have to do things. So we could do better. For example, we could just store with our data information about what kind of data it is. Say if you're trying to load production database dumps onto your staging server and want that to be reasonably up to date, what you could do, for example, is as you create the database dump, you could, say, encode into the file name of it, say the revision of it, or you could actually have it as part of the data in the SQL. It doesn't really matter. And when you load it onto your machines, you can just take note of which version am I actually working here with, so that you could just simply compare them, which is a lot easier than the naive approach, or the, I don't know, obvious approach, I guess, of trying to compare actual data sets. That's actually a hard problem to solve, to take a database dump in a database in PostgreSQL and figure out if there's any changes and do I have to load a new one, do I not? So we basically just stored some extra metadata, and that helps us to write a nice, idempotent solution to this that doesn't require us to delete our database and recreate them all the time. So anyway, enough of this little excursion. So this is our original example that just does these three things. It installs PostgreSQL, copies a config file over, and ensures that the service is actually running. And this is quite a bit of code, even though it doesn't do a lot. And in real-life playbooks, you would usually expect to see a whole lot more code, and it can become kind of overwhelming. Like you might end up with the equivalent of those 10,000, 20,000 lines Perl CGI scripts from a couple of years ago. So Ansible gives you a whole bunch of ways to sort of structure your code in a better way. And one of them is called roles. I feel it's sort of equivalent to what many other languages might call modules or classes, packages, something like that. Instead of just listing all the things that need to be done on these PostgreSQL servers, one thing you can do is just say, I want all the hosts in the PostgreSQL service group to perform the role of a PostgreSQL server. And then we're just going to define our roles. And similarly, we do the same thing for our little Picard application. And then every server in that particular group is going to be made to perform the role of a Picard server. And maybe we might also want to have the time synchronized on these machines, so we just add an extra role to basically just list which machines have to perform which roles, and Ansible is just kind of going to figure it out for us, which is a lot nicer. So let's look at how to actually write these roles. We're looking at our directory listing again, and I'm going to get rid of just the group vars and the host vars to make a little more space. And we see a new subdirectory, the roles directory, and every role in there is going to be a subdirectory of the roles directory. The NTP server one is a super simple one. So it just has one file that lists all of our tasks that we want to perform for NTP servers. And it might look something like that. Just install it, make sure it's running, done. That is probably like the easiest possible role. But you can do a lot more with it. And I want to look at that by the example of this Picard application, some Perl application. Again, it has a task subdirectory with the main entry point and possibly all the other little includes that you want to use. But in addition to that, it has a couple more subdirectories. Files, for example, is going to contain all the static files that you might need, and you just put them in that directory, and from there on, you're going to be able to refer to them in your Ansible tasks and copy them over or do whatever you want with it. Similarly, we got a templates directory, which is going to be the default lookup directory for Ansible's template module. And so we got our tasks file again. I omitted most of this. It's just going to install some Perl application, download it, start it up. Slightly more interesting is this defaults file. It is usually nice to make your roles as easy to use and requiring as little mandatory configuration as possible. And role defaults can help you with that. So this application usually runs on port 5000, so that's what we're going to provide as a default. But every use of our role is still going to be able to override this and say, I want to run 5 of these on one machine, so can't I run on the same port? So it can override that. And here's my favorite feature of roles, which is dependencies. You can do a couple of more things in this meta file, but the one I use the most are dependencies. Picard is a Perl application, so it needs Perl installed. And it's also very picky about what version it wants. So what we can do, rather than, what we can do is just include the Perl role, and every time Ansible tries to deploy Picard anywhere, it's also going to deploy Perl before it even gets there. Yes, Jay?
Can I declare dependencies on my internal stuff at version whatever?
I didn't understand that question. Can you try again?
I assume this is like apt is going to know how to ask Perl for the version, but I want to declare dependencies on other projects. If I've got projects foo, bar, and bad, and I want to say, hey, I depend on foo version 7.
So this isn't like a dependency to a package or anything. It's a dependency to another role. So in this case, we would have, in our roles directory, you would have a Perl directory, which contained an Ansible role that knew everything about how to set up Perl, whichever way you might want to do that, be it with Perl brew or whatever. And really all we're doing is we're calling into this other Ansible role, and we're passing arguments to it, like this version. And what this Ansible role is going to do with what you ask of it is like up to it. You can write a role that sets up all your package dependencies at exactly the right versions and whatnot. Like this version key isn't part of Ansible or anything. It's just a parameter that gets passed to the role. Does that answer the question? Yes, if Picard needs a Dharma, then you go to the Picard meta file and say, I depend on a Dharma. Okay. So roles are super cool, and there's a lot of them out there on the internet. There's Ansible Galaxy, which is essentially Ansible's cpan. Lots of roles for all kinds of stuff. I highly recommend checking there before you start writing anything yourself, because usually that code is going to be already somewhat battle tested and, you know, probably give you more options than what you would have come up with yourself. So we've used a whole bunch of modules so far. We've seen copy and apt and yum and command and all of that. Ansible ships with a whole bunch of those. Some very common ones, some of which I think are kind of esoteric, but in case you have trouble finding the right module to do what you want to do, or maybe you just find it a little bit bothersome to do a complex task in this weird YAML programming language, and you'd rather use a proper programming language for it, in that case, you can write your own modules. these modules, they're basically standalone programs that are going to be transferred to the systems that you're running your automation code on, and they're going to get called with the parameters, do their work there, and report back to Ansible about what they did. And the calling convention is pretty simple. You just get a chunk of JSON with all the options that have been used in the invocation of the module in the playbook. Then you do your thing, and then you emit a bunch of JSON to tell Ansible about what happened. So whether or not you succeeded, if you actually had to change something, or if it was just a no-op, or you can even return like any data structure as long as you can represent it as JSON, and then use that returned data structure further through the use of Ansible variables. And yeah, I guess I'm going to wrap up. I highly recommend using the little Ansible doc utility. It's pretty much like Perl doc, and I find it a lot easier to use than the online documentation and docs.ansible.com. Though the docs there are fine-tuned. It's like the same documentation. I just find Ansible doc a little more accessible. And we already talked about Ansible CPAN. It's called Ansible Galaxy. And that was Ansible for Programmers. Are there any questions? Over there, please.
So if the Galaxy is CPAN for Ansible, is there an equivalent installer, or do you just download and copy files?
There's a thing that does a thing. You don't download it like manually and copy stuff. Yeah, you can actually install it. I think the common way that people use it is they use. I actually forgot the command. I'm sorry, but it's. Yeah, thank you. Yeah, use that, and I think it downloads things, unpacks it, and like puts it in a particular path in your current directory, and you may choose to. Yeah. And you may choose to actually check in all those modules that you got from Ansible Galaxy into your source control system or not. It's up to you. Thank you for that. Anything else? No? Well, thank you very much.